In this video we solve problem 2 of Unit 13. In it we have a sodium chloride solution, which we can represent like this. Here we have the solution, and then we have here, for instance, the positive plate, and here we have the negative plate. Okay, so in the solution we have sodium ions, and we also have chloride ions. So the chloride ions are going to the positive plate, and the sodium ions are going to the negative plate. Okay, so we're going to for each second, so we have an amount of ions that are going to the positive plate and an amount of ions that are going to the negative plate. So we're going to call this amount of ions, of sodium ions per unit time, which are going towards the right. We're going to call that like this, and this is equal to 2.68 times 10 to the 16. Okay, so these are ions per second. And the amount of chloride ones are given by 3.92 times 10 to the 16 ions per second. Okay, so given this, they're asking what is the total current through the electrodes. Okay, so to know the total current, we can calculate the total current. It's going to flow towards the right. Okay, and it's composed by a flow of positive ions going to the right, which are the sodium ones, plus a flow of chloride negative ions going to the left. As the negative ions are going to the left, this is equivalent to a positive flow of charges going to the right, so they both add. Okay, to calculate this, we just have to apply the charge of each ion to the number of ions per second that we have. This is equal to the amount of ions that are flowing towards the right in the unit of time times the charge of each ion plus the number of chloride ions that are flowing towards the left times the charge of the chloride. And here this is in absolute value because we're already taken into account the direction. Okay, so here we know that the charge of the sodium ions is equal to the charge of the electron, which is 1.602 times 10 to the minus 19 coulombs, and this is equal to the ones of the chloride, but with a change of sign. Okay, so this is 1.602 times 10 to the minus 19 coulombs. So we can calculate the total current. We can calculate the total current as this multiplication. And if we do the calculations, if we calculate this part and this part and we add them together, this is 0.0106 amperes, which is 10.6 milliamperes.